Okay, so good morning everyone. I, Surya Prakash Das from E&TC is going to present a PowerPoint presentation. So yeah, so here are the topics. So we will discuss about data visualization in Python, and there are 8 subparts, and we will discuss about the graphs, about data visualization and everything. And these are the subparts of that graphs. And we will discuss about create 1D and 2D Numpy arrays, and we will perform array indexing and arithmetic operations on Numpy arrays. And there would be one theoretical part in this PPT also, and that is normal distribution. And at the end, there would be one code and its output. So yeah, let's begin. So data visualization in Python. So let's discuss about what is data visualization in Python. Data visualization in Python is the discipline of trying to understand data by placing it in a visual context, so that patterns, trends, and correlations that might not otherwise detected can be exposed. And here, let me tell you that why data visualization is important. Data visualization is important because it gives us clear idea of what the information by giving it visual context through maps or graphs. This makes data more natural, more human mind to comprehend, and therefore makes it easier to identify the trends and patterns with large data sets. So now let's talk about data visualization in Matplot library. Data visualization in Matplot library is the visualization library in Python for 2D plots of array. So basically, this means the creation of interactive graphics or plots is a graphical representation of data which shows the relationship between two variables or distribution of data. Now let's talk about pandas. So as you can see, it is written that it is not a data visualization library, but it is capable of creating basic plots. It simply means that if you are just creating plots, exploratory data analysis, pandas might be highly useful and practical. Also, you need to you did not need to use an additional data visualization library for such tasks. Okay. Okay, so now let's discuss about seaborne data visualization. If you will see, data visualization provides insight into the distribution and relationships between variables in a data sheet. But Seaborn is a data visualization library for Python that runs on the top of the popular Matplot library data visualization. Although although I could say it provides a simple interface and aesthetically better looking plots. So better looking plots, and yeah, it is also integrated with pandas data structure. Now we will discuss about the scatter plot, bar chart, line chart, and histogram. So scatter plot, it is used to observe relationships between variables and uses dots to represent relationship between them. The scatter plot method is matplot library is used to draw a scatter plot. And let's discuss about bar chart. So a bar chart, or we can say a bar graph, that represents categorical data with rectangular bars with heights or lengths proportional to the value that they represent. Then line chart. It is used to it is used to represent the relationship between two data, that is x and y on the different axes. And at last there is histogram. So histogram is a representation of the distribution of numerical data where the data are bind and and count for each bind is represented. So yeah, so let's talk about graphs. So here I have taken 4 graphs, and they are box plots, heat maps, pasting, and pair plots. So we're going to discuss this one by one. So firstly, box plots. This graph basically represents the minimum, maximum, median, first quartile, and third quartile in the data set. Now we'll discuss about the heat maps. It is defined as a graphical representation of data using colors to visualize the value of the matrix. Heat map is also defined by the you know heat map is also defined by the name of the shading matrix. So okay, let's talk about fasting. So basically, it is it is act of breaking data variables up across multiple subplots and combining those subplots into a single figure. So instead of one bar chart, we might have say a four arranged together in a grid. So now we can so now we will discuss about pair plots. As you can see, it is written that pair plots pair plots builds on basic two figures, the histogram and the scatter plot. So this statement means that the histogram on the diagonal allows us to see the distribution of a single variable, while the scatter plots on the upper and the lower triangles show the relationship between two variables. Okay, so let's move on forward. So our third topic was to create, one D and two D NumPy arrays. So here I have taken an example. So for one D NumPy arrays, we will import NumPy as NP b is equal to NP a range 6, and we will have b variable, and then we will run the code. So let's jump into the Anaconda. So yeah. So here we will import. Yeah, as you can, so here is the output that shows 0, 1, 2, 3, 4, 5. So now let's check its dimension. So what we need to do is that b yeah, it is the output is 1. So it means that this array is one dimensional. Okay, so now let's convert this same array to 2D. So what we need to do is that c is equals to n3. Yeah. So here is the output. So as you can see, it is a two-dimensional array, as it has rows and it has rows and it has columns. So now if we want to check its dimension, so we will simply write. Okay, so its dimension is 2. So we got the output as 2, so that it is 2D array. Okay, so now let me actually tell you the actual concept behind how we can create a 1D array, or maybe 2D array, or maybe 3D array, etc. This is called introspecting arrays. Okay, so let's start with creating an array. Okay, just 1 second. So A is equals to. So as you can see, it is a now as you can see the output. So it looks like a 3D array. And now if you want to know the size of this array, you need to put here a dot size. So it will give you the size of the array. So yeah, so it shows 30. So now here I would like to tell you a very very important concept, that how did we get the output as 30. It is very simple. See, the 3 to 5. So what we need to is that 5 into 2 is 10, and 10 into 3 is 30. So that's how you calculate the size of an array. So if you want to know the dimension, and in case data type dimension, then just simplify, put a dot ndim, it appears 3. And in case data type, then just put a data type. Let me show you. So what you need to do is that if you want to uh, you know so yeah, see, here is the dimension of this array which we have taken. The dimension is 3. And if we want to know the data type of this array, so what we need to do is that a dot d type. So we will get the output. So yeah, so float 64 as its output. So this is known as the introspecting array. By this we have created 1D and 2D array here. Okay, so now we will move forward and we will see now 1D and 2D indexing using NumPy. Okay, so here I have taken one small code. This is for 1D array for you using NumPy, and this is for 2D array using NumPy. So let's go to Anaconda and we will see that. Okay, so okay. I will create this array from list using array function so that the output is in front of you, as you can see. So if I want to access the element 4, okay, if I want to access the element 4, then index will be 3. Okay, so let me show you. Okay, yeah. So here you can see the output is 4. If you want to use negative indexing, so what we need to do is that simply put minus 2, and we will run this code. So yeah, so the output is 4 again. So in this way we can access the element from 1D array. Now let me tell you about 2D array indexing. So what we need to do is that here is the code. So I will implement this code on Anaconda. So yeah. Okay, so as it is 2D arrays, I would like to mention is that 2D arrays, it consists of basically rows and as well as columns. So import numpy as np, and then b. So yeah, so here is the output. So as we can see that 2D array, so we have created this array from nested list. So now if I want to access one, okay, now if I want to access one, so I need to mention the array name, that is b 0 0. So here we will get, as we have mentioned, 0 0 is because zeroth row and zeroth column, it gives you again 1. So if you want to use negative indexing, what you need to do is that b minus 2 minus 2. So run this code, and yeah, it is showing 1. So this is all about our 1D indexing. Okay, for 1D indexing using 1D and 2D indexing using NumPy. Here in the question it was mentioned that performing array indexing and arithmetic operation on numpy. So we have done with performing array indexing. Now we will take the topic again, arithmetic operations on numpy arrays. Okay, so here I have taken one small there are two small codes, so we will implement this thing in anaconda. Okay, so let me just remove all these. Okay, yeah. So let's see the arithmetic operation using NumPy. So yeah, there we can see we have created an array from arrange function and array 1, 2, 3, 4. Okay, from arrange function and array 1, 2, 3, 4. These are the elements in array. It contains four elements, and and array name is A. So and okay, so array name is A. So if I want to add 2 to every element of this array, then I can just mention A plus 2 and then run the code. So as I mentioned, A plus 2 and I run the code, it will add 2 to each element of the array A. I can do multiplication, I can do division also. So let me show you the multiplication. Uh, yeah, 2, 3. So we got, yeah. So we will get 3, 6, 9, 12. So this is the output, and this is for 1D arithmetic operation. Now we will see, for 2D. So we will import, numpy as np. So now we will run this code. So yeah, so here it is two-dimensional. So it is clearly, we are saying that it is two-dimensional array. So we created this array from the array function from its nested list. So I want to add any. So if I want to add any value to this, I can create, again A plus 2 and then the code. So it is showing 3, 4, 5, 6. So we can perform any other operations like these. Okay. Okay. So now let's discuss about normal distribution. So basically, the normal distribution is a form presenting data by arranging the probability distribution of each value in data. Most values remain around the mean value, making the arrangement symmetric. It is also known as Gaussian distribution or famously bell curve. And additional to this, I would like to mention some excellent properties of normal distribution. The first property is that if you will see the mean, mode, and median are will be always equal. Then the second property would be the total area under the curve would be always equal to 1. And the third property I would like to mention is that the curve is symmetric and around the mean. Okay, so now what else I can say of so yeah. So I would like to mention about the central limit theorem. The normal distribution is of high significance of the central limit theorem, and what it states that the sampling distribution of the sample means from a given population will be a normal distribution. If the sample size is large, even though the original population is not normally distributed, the distribution of sample means will follow a normal distribution. Practically, sample size of 30 or more is considered large. So here I have ended up with my theoretical part. Okay, so let me read the question. There is one question given. So data and draw a scatter plot of PIQ, VIQ, and FSIQ. Okay, so this is the code, and I have implemented this code on Jupyter Notebook also. So let's get there, and I will explain each and every line of this code. So and we will run this for output. So let's see. Okay. So here, as you can see, is that here I have imported all the necessary libraries which are required this program. So it is import panda as PD, and import matplot library as PLT, and import numpy as NP. So this first line, okay. So I'm talking about this first line right now. So what this first line would do is that it will read our data sheet only. Okay, so if it will read our data sheet, the values which are given in the data sheet, it will read that only. Okay, so what this line will do is that, and it will read only the first five rows of the data sheet. This is by default. Okay, so this will happen by default. It will read the first five rows. So yeah, here it is the output. Uh, just one second. Yeah, so you can see, so we got output so two times. I'm really very sorry. So yeah, so as you can see, here is the data given as it uh, read the first five data given in the data sheet. So with zero errors are there. So let's move forward, and let's talk about this line. So in this line, we are filling in data set for NA values, as you can see, and in this line, it will print first five rows of the data sheet by default. Okay, after this line, this thing will happen. So let me just run this code, and, and it is showing us the output. So yes, so it is both the time it is same. Okay, I don't know why it is appearing two times. So yeah, so let's talk about this line. What this line will do is that we have implemented PIQ, VIQ, and FSIQ. You know what? In this line, we are plotting scatter matrix of PIQ, VIQ, and FSIQ, as we can see, which simply stands for personal intelligence quotient, verbal intelligence quotient, and full scale intelligence quotient. And after this line, what this line will do is that in this line we have our genders, as you can see, let it be female or let it be male, in which we are giving color to the matrix based on the gender. Okay, so yeah, so what this line will do is that this line represents the setting, color scheme, and the transparency. Okay, this will do the job of, it represents the setting of color scheme and transparency. Okay, then let's move forward. What is the job of this line? So then here in this line we are capturing the figure actually, after all, by giving color to matrix based on gender, and setting color scheme and transparency. And here after this line, the second last line, we are going to we are adding subtitle actually, and given colors to the gender blue, as males and green as females. As you can see, as I have written, blue as male and green as female. So what this will do is that we are plotting the figure. Here we are plotting the figure. So by selecting this, if I will run this code, it will show me the figure. So yeah, here it is the figure, as you can see. So till now there are no errors. That means our code is correct. So yeah, it's all about this question. So yeah, I would like to mention some reference points from where I have made this project, from where I have taken some key points. So these are the three websites from where I have researched all about my project, and through that research, I have made points and subpoints, and I made this whole project. Okay, so thank you so much. Have a very, very, very nice day.